Welcome to the most complete mixed reality tutorial on the internet, where we will build together this mixed reality game from scratch using the Unity game engine and a MetaQuest headset. Not only this tutorial series will teach you the basics to set up Passthrough and use the scene model, but this series is designed to break down the most important feature of mixed reality. For example, the ray gun will teach you how to collide with the player environment to stop the ray and display an impact. The ghost and the orb they are trying to eat will teach you how to spawn an object in the player environment. The ghost movement will teach you how to use Navmesh to navigate in the scene. The flashlight will teach you about some nice stencil effect that you can do, and so much more. But to me, one of the coolest things when making this kind of step-by-step tutorial is that I get also the opportunity to teach you some secrets that are often missing on tutorials. For example, making a shader for the ghost, doing a little bit of 3D modeling, adding sound effects, do some optimization for the game to run smoothly, and of course, publishing the game. Now, if you want to have a look at the different part of the video, I will leave some timestamp in the timeline. Now, this tutorial is actually a merge of my previous videos on how to make a XR game in one single video, which I hope will make it easier for you guys to navigate and follow along. You can get access to the complete source code of this project on my Patreon, where I'm sharing not only the code of my tutorials, but also exclusive content. I'm Valem, and this is Valem Tutorials, a YouTube channel dedicated to XR development, so feel free to like and subscribe to not miss the next video. But without further ado, let's get started. Okay, so the first step to make a mixed reality game with Unity is to download the Unity Hub, which you can do so on this webpage that you will find in the description down below. You can then click on download over there, and this should allow you to have here the Unity Hub running. Beautiful. Then, of course, you need to install one version of Unity, which you can do so over there on install and by clicking on install editor. As you can see, these are all of the Unity version that I have in my project. For this tutorial, any version above 2021.3 should work. Now, just note that for Unity 6, there is currently a bug running for mixed reality, so don't do this one or wait for it to be resolved. But anyway, what you really want to make sure when installing a Unity version is to have Android over there that is being written, which you can do by simply clicking over there and then on add module and selecting here the Android build support with both OpenJDK and Android SDK and NDK tools, or directly when you first install it from install editor. If you select one version, you can directly install it from here right away by enabling it over there. Now anyway, now that you have a Unity version that has both Android and Windows, you can create your own Unity project. So let's go to project, click on new project over there. Here you can select a Unity version. I'm going to select 2022.3. For the template, let's select the Universal 3D. Now the Universal 3D means that we are using the Universal Rendering Pipeline, or URP, which will allow us to have a more optimized rendering pipeline for our game, which will work well for mixed reality. Now anyway, we can give a project name. I'm going to name mine Ghost Hunter. Beautiful. We can set a location, a Unity organization. Then in my case, I'm going to disable the connect to Unity Cloud, and then we can click on create project and wait for Unity to set up everything for us. And there you go, Unity has finally opened, and now it is time for the annoying part where we will need to download the tools and do the setup for making mixed reality work within Unity. But don't worry, this will be soon over and we will be able to get started on making our mixed reality game. Now anyway, let's remove the README asset because we don't need it. Click on proceed, beautiful. And because we are building for the MetaQuest device, this means that we will need to have as a building platform Android. To do so, we can go to File, Build Settings, and let me resize this window. You should see over there the Android. Currently, Windows is selected, but if we select the Android and then click on Switch Platform, this will, as the name suggests, switch the platform correctly to Android, which will allow us to build our application to the Quest headset. Beautiful, now that we are on the correct platform, we need to install the MetaXR all-in-one SDK, which will contain all the tools to create a mixed reality game. To do so, you need to go on the asset store and search for the MetaXR all-in-one SDK, and this should land you to this asset right there. By the way, if you want to save some seconds, you will be able to find the direct link to this asset in the description down below. Now anyway, we can first click on download here. Now in my case, I have previously downloaded, so I just need to click on open in Unity. And if you click on open Unity editor, this should directly open the package manager, as you can see, with the Meta XR all-in-one SDK selected. Now the version that we will use is 68, but any version above this one should work, and if anything changes, make sure to go to the comment section down below where I will write anything that you need to do to fix any issue that you should have. Now anyway, to download the Meta XR all-in-one SDK, we can simply click on install over there and wait just a little bit. Okay, it has been installed and now asking us to restart the editor, so let's say yes. And there you go. If we go at the top and that we go to in project, we can see that the Meta XR all-in-one SDK has been correctly installed with all of its core components. This is awesome. So now that is the point where we need to do some settings on the project. It used to be a very annoying task to do, but thanks to a new feature from the Meta SDK called the Project Setup tool, we will be able to do so in a few seconds. But first, let's close here the package manager, go to Edit, Project Settings, and if we go to XR Plugin Management, let's click on Install XR Plugin Management. There we go. Now by downloading the XR Plugin Management, we are telling Unity that we are making a VR or XR game. And here on the Android panel, as you can see, this is where we can set the plugin providers. In our case, we are using the MetaQuest, so let's enable here Oculus, which is, as you know, the old name from the MetaQuest. There you go. So this will allow us to have VR working on Android, but let's go to desktop now and do the same. And now this is where things get interesting, because if we go to Meta XR over there, as you can see, we have the project setup tool opening. And this is what I was just talking you about, which is an awesome tool to make sure that every setup is done correctly inside Unity to make mixed reality works. Now, as you can see, we have some issue currently for both desktop and Android, but we can fix them quite easily by clicking here on the Fix All. Then we can click on Apply All. And there you go. As you can see, everything seems to be good now. We have no more issue on Android, and we can even see that XR is now ready for Android over there. That's awesome. Now what's left is to go to PC, and now we can do the same. We have just one issue currently, so let's click on Fix. And there you go. Everything seems to be good now. And as I was telling you, this is really awesome. You can have a look at all of the little settings that this tool has changed, and that will make sure that mixed reality is running properly within Unity. Now we can close these windows, and the boring part of this tutorial is finally over, because we can now directly build our mixed reality game. So there are multiple ways that we can get started to build our mixed reality game, but because this is a beginner-friendly tutorial, I want to share with you another awesome tool by the Meta XR all-in-one SDK, which is the building blocks. If we go to Meta over there, then on Tools, and then on Building Blocks, this is what you should see, a new window that contains a lot of things. So basically what building blocks are, these are a quick way to add some feature inside your Unity project by simply dragging one of these blocks directly in the hierarchy. For example, here we have the camera rig, which is the most basic component of them all, and that will allow us to have a camera rig for our player inside our game. And that will allow us also to track the position of the controller. So let's simply select it and drag it over there on the hierarchy. And as you can see, this has created a new game object that contains a VR manager. As you can see, this component is super long and contains some settings for our game. Now, if we go down below over there, we can see that it also contains a camera on the center eye ensure, and that we have the left hand and the right hand ensure that will follow our controllers. Now anyway, because we have created a camera rig that contains a camera, we can select the default camera that was sitting on the scene before and press on the delete key to remove it. We can also do so with the global volume, which adds some post-processing that we don't want, so let's press on delete. And there you go, now it has been removed. But then now that we have a camera rig, because we are making a mixed reality game, we also want to have Passthrough working, so let's simply select these building blocks and drag it as well on the hierarchy. And as you can see, this will add a Novia Passthrough layer component to show the Passthrough, but it will also go on the camera rig and change some settings, like this one. As you can see, this has enabled the Passthrough now on the OVR manager. So basically, building blocks are a quick way to make sure that everything is running correctly. But of course, if you are a more advanced developer, don't worry, we'll do so much more than using building blocks on this tutorial series, you will see. Now on the quick notes, you can see that we have a little icon showing over there with a little red dot. So this icon is actually telling us that there are some issue within our project settings. So if we click on it, we can see that there is one issue from the project setup tool. So if we click over there, as you can see, this opened the project setup tool from before. But now because we have made a mixed reality application with Passthrough, we can see that there are some new issues that we want to fix. And you already know how to fix them. We simply need to click on fix all over there, then on apply all over there. We can do so as well for desktop. There you go, make sure that everything is working as well for desktop, but don't worry about the last issue. We don't need to fix it right now, so let's close this window. And now at this state, we have a mixed reality application working. But of course, the big question is, how can we know? Well, in other words, how can we test our game? And this is what I'm going to share with you now. Okay, so there are basically two ways of testing our game. The first one is to build it and export it directly to the Quest headset. To do so, the first step is to set your Quest to developer mode, which you can do from the MetaQuest mobile application. I will leave in the description a step-by-step tutorial to do so. Then you can plug your MetaQuest headset with a USB-C cable to your computer. And from here, it is very simple. You need to go to File, Build Settings. You should have this window showing with the Android platform selected. And if you've authorized the connection of the headset through the computer, you should see here over there on the list of the run device, which means that we will be able to build the game and export it directly to this device at the end. So let's try this out. Let's simply click on build and run, give a name to the build like test, and click on save. Now we just have to wait a little bit. And there you go. After waiting a little bit, the build has been successful. If we click over there, this should open the console window. And as you can see, after waiting a little bit less than 10 minutes, the build has been completed with a result of succeeded. And now if you put on your VR headset, this is what you should see. As you can see, now we are inside the application that we just made. And Passthrough is working. I can see the computer in front of me. Now, by the way, if you have some issue when building the application, you can click on player setting over there, then on other settings. And if we go here on identification for the package name, it is better to replace this by something like com.your company name. So let's do Valem and then dot the product name, which is Ghost Hunter. Beautiful. Because otherwise, if two package names are the same for different projects, it doesn't allow you to build. So anyway, we can close these windows. And of course, now that you've seen this first method, as you can see, this is super slow to test. Of course, this means that if you are making some change on your application, you will need to always build your application to test these changes. But what if I told you that there was a way to test directly our mixed reality application within Unity? So for this second method, what you need to do is actually to have the MetaQuest link running. This is an application that you will be able to download, link in the description again. And now with this application, if you connect your Quest headset to your PC with a USB-C cable, you should see it over there like mine. And from here, what you need to do is go to MetaQuest link and then click on launch like this. And after waiting a little bit, you should see this white background, which will tell you that everything is working and that now you are ready to test your mixed reality application directly within your computer. But just before to do so, there are some settings that you need to make sure you have. If we go to settings over there, then on general, make sure that unknown source is enabled. And then if you go to beta, make sure that you have both Passthrough over MetaQuest link enabled as well as spatial data over MetaQuest link. This will make sure that, well, as the name suggests, both Passthrough and the spatial data will work this way. Now we can minimize this window. And then let's click on play to find out if it is working. And there you go. As you can see, it is working. If I move my head, you can see that the camera is as well moving. I can see my real surrounding. I can even move my hand and everything seems to work. But in your case, all that you see here is a black screen. but I can guarantee you that in the VR headset it is working. It is that for some reason Meta doesn't allow the pass-through to show within the game window over there, but inside the headset it is working. And so it is using this second method that you should be able to directly make some change and test them directly inside Unity without having to rebuild every time. Okay, so now that we know how to test your mixed reality application, let's get started on making the awesome raygun that you saw in the introduction. Okay, so for our raygun, we of course need an awesome 3D model, and as you can see, I just found this one on Sketchfab, which looks really cool. There it is on Sketchfab. I will leave in the description this link if you want to download it as well. You simply need to click here on download 3D model and then download the FBX version to drag it here in this project. Now, of course, we want this raygun to follow the one of the hand, so I'm going to simply drag it as a child of the right hand ensure. So here it is, we can see it over there. We can rename it raygun like this. But if I click on play, you can see that the raygun is following the right hand correctly, but it's not facing the good direction. So the reason is that if we leave play mode, we can see that the blue axis over there doesn't point to the same direction as the gun, and this blue axis represents the forward axis of the controller. So what we can do is simply rotate the raygun 90 degrees on the y-axis. And now if we compare it to the parent, we can see that the forward axis of the parent, which is the forward axis of the controllers, is pointing at the good direction. Also, we can see that the starting position of the raygun is over there, which is the position of the wrist. So what I like to do is select the raygun and just increase a little bit its position, like so. So that if I select the right hand ensure, it is placed approximately over there near the handle. But of course, what we want with this raygun is be able to shoot laser with it. So to do so, I'm going to select the raygun, click on add component, and add a new component called raygun. There you go. So on this script, what we need is a reference to a row button by doing public OVR input dot row button that we can call shooting button. There you go. This way, if in the update function, which is called every frame of the game, if we do if OVR input dot get down and that we use our shooting button, then this way we will be able to listen to the button press of the player to trigger anything that we want. So in our case, I'm going to create a public void function called shoot. Beautiful. And I'm going to simply call this shoot function over there. Now, just for testing right now, what we can do is simply write debug.log pew pew just to see if this button is working. Now let's save with Ctrl S, go back to Unity. There you go. We can see our script over there on the raygun and we can choose a shooting button. Now in my case, I'm going to select the right index trigger. We can save, and now if we click on play, there you go. If I press on the trigger button, as you can see, the pew pew is working, which means that we are able to listen to the trigger button. But of course, more than writing something in the debug console, what we want is to show a laser. So what we need to do is instantiate a line when we shoot instead of writing some text. So for this, let's right click in the hierarchy, go to create empty, and I'm going to call this one red line. Beautiful. We can click on add component and add a line renderer. Now, as you can see, the line is pink right now because it doesn't have a material. So we can go to material over there, click on the right and search for line. Beautiful. You should see here this default line material showing, which will turn everything to white. And we can actually change the color over there by clicking here. You can either select one of the gradient over there, but in my case, I'm simply going to set the start color to red and the end color as well to red. If you'd like, you can also select the first element at the top and change the alpha value to maybe 200 and do the same at the end with a value like 200 or more or less, depending on what you want the end to look like. Now, anyway, we can close the gradient editor. But as you can see, the size is a bit too big. So what we can do is actually select the white here and drag it down like this till it seems a bit nicer, like this. And there you go, we have now created our beautiful red line that we can instantiate when we shoot. Now, by the way, if we go to position, we can also change the start and end position of this line, and this is what we will be able to do so using our Raygun script. But for now, let's simply select our red line and drag it in the project folder. This way, as you can see, this will save this game object in our project, and this means that we will be able to instantiate it. Now we can select the one that we add on the hierarchy and press on delete to remove it because we don't need it. And now let's go back to the Raygun script to be able to instantiate this line. Okay, so what we need is a public reference to the line prefab that we can call line prefab. And I will also need two new parameters. The first one is a public transform called shooting point, which will be the start of the line. And then we can use the direction of the shooting point, but what we want is actually a max line distance value that we can set initially to maybe 5, and that we can use to set the line length. Now anyway, in the shooting function, what we can do is instantiate the line by doing line renderer line equals instantiate line prefab. Beautiful. Oh, and by the way, here I'm making a mistake because I'm actually getting the line as a line renderer, but at the top I set the line prefab to be a game object, and this is wrong. We should write line renderer over there as well, and this way, as you can see, this is properly casted. Now anyway, we can set the line position count to be equals to 2, which means that there will only be 2 points on our line. And we can set the first position with set position 0 and the position to be the shooting point dot position. Beautiful. Now for the endpoint, let's simply do vector3 endpoint equals shooting point dot position plus shooting point dot forward multiplied by the max line distance. Now if you don't know what I'm doing over there with this, if this is our Raygun and that this is the shooting point over there, if we want to get the endpoint position, we can actually get this position by adding to this position this vector, which is computed by simply multiplying the shooting point dot forward, so the forward axis over there, by the max line distance. And this is how we can get here this endpoint. Anyway, now that we've computed the endpoint, we can do line.setPosition 1 endpoint. And there you go. Now, after we've instantiated this line, a good thing would be to actually destroy it after a certain amount of time. So at the top, I'm going to add a new public float variable called line show timer and set it to maybe 0.3. This way, what we can do is write destroy line.gameObject line show timer, and this will actually destroy the line.gameObject after waiting here this time. And there you go, guys. I think that we are already ready. We are now instantiating a line, setting its position. It is now time to save and go back to Unity. There you go. As you can see, we can see all of the new parameters that we've just created. For the line prefab, we can simply drag the red line over there. Now for the shooting point, this is the start position of the line. So what we can do is right click on the Raygun, create an empty that we can call shooting point. And what we can actually do is move this empty game object at the very tip of the Raygun like this. But remember that we are also using the forward axis of the shooting points, which is here this blue axis. So make sure here to set the rotation to -90. This way, as you can see, the blue axis will be correctly set to point in the direction of the gun for the shooting point. Now let's go back to the Raygun and drag this shooting point over there. For the max line distance, we can keep it to 5, and for the line show timer, we can keep it to 0.3. And now everything is ready. We can click on play to find out if we are now able to shoot some laser from our Raygun. And there you go, as you can see, it works. I can shoot with the Raygun, but of course right now, what does not work is that the ray is not stopped by anything. It would be really nice if the ray would stop where it meets our wall, ceiling, floor and furnitures, and this is what's exactly possible with the scene model by Meta. So if you don't know what the scene model is, this is a new functionalities on the Meta Quest for mixed reality that allow you to scan your room to create some data over the player's environment. And this data, we can actually access it on our game. So you guessed it, this is what we'll use to know if our ray is colliding with something. So the quickest way to set up the scene model in Unity is from the building blocks. If we go at the top to building blocks, here they are again. we can actually click on the scene right here at the top, and you should see the effect mesh building blocks. If we drag these building blocks in the hierarchy, as you can see, this now creates two things. First, the MR utility kit, and then the effect mesh. So the MR utility kit is what will actually get the scene model data. As you can see, it has a world lock that prevents the player to move the scene model when it is recentering. And if we have a look down below, you can see that the MRUK is set to device with prefab fallback, which means that if it does not get any data from the device, it will launch a default prefab among this list, which is also super useful to quickly debug multiple rooms. But what can we do with the scene model? This is what the effect mesh is for. As you can see, the effect mesh will spawn on start and will create for each scene model element a mesh and then assign it this material right here. By the way, if we go down below, you can see that there is also settings to add collider, which we will use in a minute for our ray gun. There is a setting to hide the mesh, but also for the labels. If we click on the label parameter, this is where you can say for which scene model label you want to add a mesh. Right now it is set to everything, so make sure that the global mesh down here is disabled, because the global mesh is basically the complete detailed scan of the room, which we don't want. And there you go. Now that everything is ready, let's find out how the effect mesh looks like by clicking on play. And there you go, this is what you should see. Not exactly this, of course, because this is the scene model from my office. But as you can see, we have a bluish bounding box for all of our furnitures and even for the wall, ceiling and floor. This is cool. And as you can see, if we go under here, this game object, we can have a look at all of the different furniture that was able to be gathered from the scene model by Meta and that now we can use inside our mixed reality game. We have the wall, the ceiling, the floor, but also the desk here, which is super nice. But in my case, I actually don't want any visual or material on the model. I just want to have the colliders to be able to stop the line from the ray gun. So let's leave play mode. And what we can do on the effect mesh is here, we can hide the mesh by clicking over there and we can enable the collider. This way, if I click on play, there you go, we cannot see anything right now. But if we select our room, we can see that a collider has been created for all of its elements. But now that we have collider, we will be able to use this information to stop our line from the ray. So let's leave play mode. Let's save and go back to the ray gun to find out how we can do this. Okay, so to be able to find out if something is in front of the ray when we shoot, we will actually use a ray cast. So let's go at the top and after we write the debug.log that we actually don't need. So let me remove this. What we need to do is create a new ray with ray equals new ray. We can give as a start position the shooting point.position. As a direction, we can use the shooting point.forward. And then we can find out if there is a collider that meets the ray by doing bool has hit equals physics dot raycast with our ray. For the output, we can write raycast hits and then our max line distance. This will be the maximum distance of the ray. And the last setting that we need is a layer mask. So if we go at the top, we can write public layer mask and call this one layer mask simply. We can write it at the end like so. And there you go. Now simply using this line of code, we'll be able to know if we have hit something or not. So in our case, if we have hit something, this is where we can stop the ray. And if we have not hit something, this is where we can do the thing that we did before, which is simply give the endpoint this default value. So actually, let me go at the top and write vector3 endpoint, and we can actually initialize it to vector3.0, and we can simply cut and paste this line of code and remove the vector3 in front, and there you go. This means that when we have not hit something, we set the endpoint to the default value, but if we have hit something, what we can do is simply set the endpoint to be hit.point, which is the position where the ray has found a collider. And there you go, it is as simple as this. We are actually doing nothing more than before. but just using some physics to find out if there is a collider from our real world, and if there is a collider that meets our ray, then we set the endpoint to be the hit position. There it is, so now let's save the script and go back to Unity. Okay, so there is not a lot to set up inside the Raygun script. Just make sure here that the layer mask is set to default. This means that we will be able to find all of the colliders that are on this layer. And now one thing is missing, and it is to find out if this is working by clicking on play. And there it is, look at how cool this is. Thanks to the scene model, we are now able to use some colliders on the wall, on the ceiling, but also on the furnitures that we are using to stop the ray. But I think that we can still improve this awesome Raygun in two ways. First, we will add a sound to be played when we shoot, and then I also want to add a certain impact on the wall to also show you how we can get the normal information of the object that we collide with. Okay, so for the sound, I'm going to use this awesome free sound that I found on this website and that you will be able to find in the description down below. As you can see, it is kind of cool. Now anyway, we can download the sound and directly import it inside our project, like this. And if we want the sound to be played when we shoot, we can then go on the Raygun and add an audio source. Beautiful. We can remove the play on awake and set the spatial blend to 3D. Now we can go back to the Raygun, and I'm going to add at the end a public audio source for the reference to the audio sounds that we've added, and then a public audio clip for the shooting audio clip that we've downloaded. And now when we shoot, what we can do is simply do source.play one shot shooting audio clip. Beautiful. We can save, go back to Unity, and we can drag the audio source for the source and the audio that we've downloaded for the audio clip. Beautiful. And now let's just click on play to find out if the sound works. And there it is. As you can see, you should be able to hear an awesome sound effect when we shoot. This is super cool. And as you can see, we were able to make this in just a few seconds. But now for the second improvement, which is adding an impact on the ray, what I'm going to do is right click, go to 3D object and go to quad. Now, as you can see, this will create a 2D quad. And this is what I'm going to use to create an impact effect. We want to change the material on this quad. So let's right click, go to create, then on material and call it ray impact. Beautiful. At the top, we can change the shader to universal render pipeline unlit. We can set the surface type to transparent and the blending mode to additive. Beautiful. Now for a texture, what I'm going to do is click here and I'm going to search for particles and use here this default particle texture. Beautiful. We can now drag the ray impact material to the quad, and this is what it should look like. As you can see, it works pretty well. But in my case, I think it will be even better if I change the color from white to red. And here it is. It is looking nice. Now, if you want, you can change the size of the impact to anything that you want, but I think a value of 111 will be good enough. So let's simply rename this to Ray Impact and drag this game object in the project folder for turning it into a prefab. Now we can select the one on the hierarchy and remove it. And then let's go back to our Raygun script to be able to instantiate this impact when we shoot. There we go. So at the top, in the same way that we've instantiated the line prefab renderer, let's simply add a public game object called Ray Impact prefab. Beautiful. That we'll be able to instantiate as well. So what we can actually do is instantiate this one with game object Ray Impact equals instantiate Ray Impact prefab. Then we can directly set its position to be it.point. But this is where things get interesting, because now what we want is to actually set the rotation of the impact to be the same rotation as the surface that we are hitting. So for example, let's say that this is our surface and that this is our ray over there. Where the ray is meeting the surface, what of course we want to do is orientate the impact in this direction, okay? So to do so, what we need is to actually get the normal and create a rotation with the normal that we just hit. So for this, let's write quaternion Ray Impact rotation equals quaternion dot look rotation minus it dot normal. There you go. So here with the it dot normal, we are getting the normal value of the position that we hit. So in other words, we are getting this value right there, and we can actually create a rotation from it by calling the quaternion dot look rotation. And here I'm just adding a minus in front because if we go to our ray impact over there, so let's double click on it, we can see that the forward axis is actually on the opposite side of the showing face. So that's why I need to set it to the opposite direction of the normal that we hit. Now let's go back to the scene by clicking here. Let's go back to Visual Studio and let's simply add the ray impact rotation at the end right here. Beautiful. And now that we've instantiated a ray impact, we can actually destroy it after, let's say, 1 second. Beautiful. And now everything should work. With this, you have seen how we can actually spawn an object to the hit position, but also change its orientation from the normal that we hit. So let's go back to Unity. And for the ray gun, let's simply drag the ray impact prefab over there. And now everything should be ready. One thing still missing, and it is to test our game. And there you go, guys, look at what we just made! The coolest ray gun ever! Now, as you can see, the sound effect and the ray impact add so much more realism, it is so cool! But of course, this is only the beginning. Thank you for watching, and see you very soon. Bye bye! Welcome to the second part of this big tutorial series that will show you how to make a mixed reality game for the MetaQuest in Unity. Now, after doing the XR setup and making this cool ray gun in the previous episode, in this video, we are going to make the star of the show, the ghost. Not only we will build the ghost together in Blender and make the ghost shader using shader graph, but I'm also going to show you how we can use the player's real-world information to spawn the ghost behind the wall. Now, if you haven't already, now is a good time to subscribe because in the next episode, I will show you how we can create a Navmesh to let the ghost move and avoid obstacles in the real world to reach the orbs. As always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. So, without further ado, let's get started with our tutorial. And there it is, guys, we are where we were left at the end of last episode with our beautiful ray gun. Now it is time to make the star of the show, the ghost. And for this, we are going to make our own 3D model in Blender. So be kind, please, because yeah, it's the first time that I'm using Blender for a tutorial. So anyway, if we open Blender, which you will be able to download in the link you will find in the description below, there you go. We have 3 things here. A camera that we can delete if we right click and then click on delete. Do the same for the cube and the same for the light, and we should be left with an empty scene. Beautiful. But now to create the ghost, we are going to first create a sphere. So we can go at the top, add mesh, and there we are going to add a new V-sphere. But as you can see, the sphere is not very much detailed. So what we can do is go up there, and what I'm going to do is write 64 and then 32. Basically, as you can see, this will double the amount of quad that are on the sphere right now, which will make it a bit more defined. Now, anyway, you can see that the shading is a bit weird right now because it shows all of the little squares. So what we can do is actually right click and click on Shade Smooth. And as you can see, it is super smooth as the sphere should be. So that's really nice. Okay, so now it's time to do some 3D modeling. So what I'm going to do is press on the tab key, and as you can see, we have now showing all of the little vertices of our 3D model. And what we are going to do is actually select the 3D model at the end right there. But if we press on the G key, as you can see, we can move the vertices, but not the one that are around it. So let me press on Ctrl Z to go back to where we were. And what I'm going to do to fix this is click over there. Now, as you can see, if I press on the G key, you can see that there is a kind of big circle now. And if you scroll, you can actually change the size of the circle. And this means now that you are able to move all of the neighbor of the vertices that you are grabbing. Now, let me press on Ctrl Z because we are going to use this exact technique, but we are going to use it on a certain axis. So follow as I'm doing here. You can press over there. Then we are going to click on the scroll wheel to go on this side, and we can press on the Y key. This will force us to have this view where the X direction is on our left and our Z direction is upward. This means that now with the vertices that we have selected, if we press on the G key, we can move it and force the movement to be vertical, which is what we want. And there you go. If we increase a little bit the size of the neighboring effect, there you go. If we left click, this is what we have left. We have successfully managed to edit our beautiful shape like we want it. And I guess that this is already nice, but I think it would be also great to add some arms to the shape. So let's go to the X view over there to face the ghost forward. And what we can do is select one of the edges again, press on G. Now I'm going to reduce the size, and we can go to the left to create some little arms for our ghost. We can do the same with the other edges at the opposite side and move it like this. And there you go. Our ghost is made. And as you can see, it already looks good. For the eye, don't worry, we will set up them inside Unity. But I think already with this, we have kind of a ghostly shape, which is kind of nice. So let's select this shape over there. We can actually rename it Ghost. And I'm going to go to File, Export, FBX. There you go. Make sure that the limit is set to selected object. And now we can save the 3D model anywhere that we want to. Congratulations, at this stage you've managed to make your own 3D model using Blender. So we can simply select it over there and drag it inside Unity. Right there. And we should see it. There you go. We have our ghost showing. That's beautiful. I'm going to drag it in the hierarchy. And we can see it over there. But as you can see, our ghost is a little too big, but for some reason the scale is set to 100. So let's set it back to 111 on all axes. But now it is a bit too small. So what we can do is actually go to the ghost model, and on the scale factor, I'm going to set the scale to 10 and then click on apply. And there it is. We have our beautiful ghost, which we can scale as we want. But as you can see, the forward axis of the ghost doesn't point into the blue axis, that is this one right there, which I don't like. So what we can do is actually right click on the ghost and click on create empty parent. Now, as the name suggests, this will create an empty parent for our ghost, which we can call ghost. Beautiful. And now we can take the child, and what we want to do is rotate the child so that it points into the blue direction that we have on the parent. So let's select it right there and rotate it 90 degrees on this direction. Beautiful. So the direction should be minus 90, 90. And here you go. Now, if we have a look at the parent, this is what we have. We have a beautiful 3D model that has been correctly scaled, but also that has a correct forward axis. Now that's beautiful, but something is missing on the ghost, and it is, of course, the eyes. So for the eyes, what we are going to do is use here this simple 2D image that I've quickly made on Photoshop. You should be able to download it in the description down below with as well the ghost 3D model if you want to use the exact one that I'm using right there. We can drag the eyes in the Unity project. And what I'm going to do is right click on the ghost, go to 3D object, and then go on quad. Beautiful. Now, as you can see, this creates a quad, which we can rotate 180 degrees, that we can scale down, and that we can place in front of the ghost, like so. And now what we can do is drag here the ghost eyes on the quad that we just made, and this should by default create a material. So right now the material is the ghost eye, which you can see right there. But as you can see, the shader is set to Universal Render Pipeline Lit, which is something we don't want. So let's go to Universal Render Pipeline and set it to Unlit, because we don't want it to have any lighting information. For the Surface tab, we want it to be transparent, right there. And now, as you can see, this seems to work well. We can scale the eyes like we want, put them like so. And there you go. As you can see, our ghost has some beautiful eyes right now. But of course, right now, the ghost material is not done. So this is what we are going to do by simply creating our own shader using Shader Graph. Okay, so to create our own shader, we can right click in the project windows, create, then we can go on shader graph above, and then we are going to go to URP and select the unlit shader graph. Because you want a shader that is not lit, we can call this one ghost shader. Beautiful. We can then click on open shader editor. And this is what you should see. So this is the shader graph, which will allow us to create some shader by dragging some nodes. And you will see we will make a very, very simple shader. But first, we need to do some settings on the window that you should see over there. And the only setting that we need to do is set the surface type to transparent. Beautiful. Now for the shader itself, what I'd like to do is create a ghost Fresnel effect. So I'm going to right click, create node, and search for Fresnel. Beautiful. Now already, if we drag this Fresnel effect to the base color and that we save, there you go. Now let's create a material with this ghost shader. For this, we can right click on the ghost shader, go to create, and then on material. And as you can see, by default, this will create a material that has the ghost shader because we have right clicked on the ghost shader. We can rename this one ghost material and we can assign it to our ghost. And as you can see already by default, we have a very, very nice effect. But at this point, something a bit annoying is that we have no settings here to tweak the look of our effect. So what we can do is go back to the ghost shader and add some settings over there. Now, the first setting that I'm going to do is here, you can see that there is a power float. So if we click on the plus button, float, I'm going to call this one power. We can drag it over there and drag the power node to the power variable. And now if we save and go back to Unity, you can see that now with the power setting, I can change the intensity of the Fresnel effect. So that's one good thing. Now, if we create not this time a float, but a color, which we can still call color, and that we drag it over there, what I like to do is change the default color of the Fresnel effect. And to do so, we can actually multiply the result of the Fresnel effect by the color. So let's right click, create node, search for multiply, press on enter, drag the color for the first variable and the Fresnel effect for the second one. And then with the result that we have, so the output, we can override the base color that we had. And basically just like this, if we save, go back to Unity, you can see that everything is pitch black now. But if I change the color to something, let's say, yeah, bluish, as you can see, this works. Now I have two settings. I can either change the color of the Fresnel effect, but I can also change the power itself. But as you can see, there is an issue. The issue is that our ghost is not transparent. And what we'd like is to, instead of having a black color on the inside, we want this color to be transparent. And this, we can do so if we go back to our shader. Now, let me do a rectangular selection over there and drag everything to the left to make some room here. And what I'm going to do is use the alpha value of the color that we have here for the alpha parameters over there. So let's right click, create node, and go to split. And if we drag the output over there, this means that we can split the color into the four components of the color, so RGBA, A being the alpha channel. And if we drag the alpha channel to the alpha value on the shader and that we save, as you can see, everything is transparent. But if we go to the color and that we increase the alpha value to the max, as you can see, this is working now. And now with everything, we can tweak the transparency, the power effect, as well as the color. As you can see, everything is working super nice. You can even make a red ghost like this. I think the effect looks really great. Now, anyway, at this point, we have succeeded to create our beautiful ghost 3D model with the beautiful eyes, with the beautiful shader. So congratulations. But now this is the second part of this tutorial, which is very important. And it is how should we instantiate this ghost inside the player's environment. Okay, so to post our beautiful ghost over time, what I'm going to do is drag the ghost in the project window to turn it into a prefab. This way it will save us into the file of our game and we can remove the one that we have here. I'm going to right click, create empty and create a ghost spawner. Beautiful. We can add as a component a ghost spawner component as well. And here for the position of this game object, let me reset it to 0, 0, 0 so that everything looks a bit better. And let's open this script inside Visual Studio. Okay, so if you wanted to spawn a prefab over time for a traditional game, which is not XR, this is what you would do. First, you get a public float spawn timer, which we can initialize maybe to, 1 second. Then you will use a private float timer to count the time that is passing. And you will have a reference to the prefab that you want to spawn, so the prefab to spawn. And simply using this value in the update function, what we can do is increase the timer with timer plus equal delta time. And if the timer is greater than the spawn time, this means that we can instantiate our ghost. So I'm going to write a new function called public void spawn ghost. And inside this function, if we wanted to make a traditional non-XR game, what we could do is simply instantiate our ghost prefab with instantiate prefab to spawn. There we go, and we could call here the spawn ghost when the timer is greater than the spawn times. And then we can reset the timer by doing timer minus equals spawn timer. Beautiful. So if we wanted to give a random position to our ghost just to test, we could do, for example, vector3 random position equals random dot. We could do inside unit sphere and multiply by a certain distance, like 3. So this means that the random position is somewhere inside a sphere that has a radius of 3. And maybe what we can do is set the y to 0 so that it is on the ground. And now we can instantiate the ghost at the random position. And for the rotation, we can do quaternion.identity. Beautiful. And there we go. We can save our script as simple as this and go back to Unity. And now let's find out how this default spawner would look like and why it won't work for our mixed reality game. Of course, don't forget to drag here our ghost prefab inside the prefab to spawn. And there you go. If we click on play, as you can see, it is working. One ghost is spawning every second, but as you can see, because we have made a random position, well, sometimes in some cases, the ghost doesn't spawn inside the room, sometimes it spawns inside a furnitures, sometimes it spawns in some places where it might be stuck, so this is of course a big problem, and this is what we can actually fix by reading some of the data from the scene model. Let's leave play mode, and here what I'm going to do is actually update the ghost spawner to take into consideration the scene model. Now, in my case, I want the ghost to spawn behind the wall of the player so that the ghost could go through the wall like a ghost and eat an orb that will spawn in the room of the player. Now, before showing you how to do this inside the ghost spawner, I highly suggest you to do the following. If we right-click, create empty, and that we search for find spawn position, you can see that there is already a script that is made by Meta that actually finds some spawn position. As you can see, you can set the spawn location to be floating, vertical surfaces, hanging down. You can set the different labels of where you want the spawn to occur. You can set the max iteration in case it fails and you want to iterate again for a new position. We are not going to use this script inside this tutorial, but what I highly suggest you to do is read a little bit of it to understand how some of these elements can be done, because the script is really well made in my opinion, and it actually uses also the size of the object to know where it needs to spawn. But we are going to do a simpler version than the script, so anyway, let me select the game object that we created, delete it, go back to the ghost spawner and open the ghost spawner script. Okay, so let's get started on the random position. So the first thing that we want to do in the spawn ghost is do mruk room. And now the mruk room is not recognized because if we click over there, you can see that we need to write at the top using meta.xr.mr utility kit. So let's do so using meta.xr.mr utility kit. There you go. Now we have the mruk room, and if we do room equals mruk.instance dot get current room. There you go. This will give us the data for the current room. But of course, there might be an issue right there if the MRUK room is not set up or initialized. So what we can actually do is in the update function, if MRUK.instance, if there is no MRUK.instance and that MRUK.instance is not initialized, then we can simply return. So this will make sure that the room is in fact initialized. Now anyway, with the room data that we have, this is where we can use some magic, because there is a very, very important function inside the MRUK room, and it is room.generate random position on surface. You can even see that there is a one for random position in room, but the one that we are looking for is the random position on surface. Beautiful. Now, as you can see, the script needs multiple parameters. The first one is the MRUK surface type. And as you can see, we can set if it's facing down, up, or vertical. Now, in our case, we want it to be vertical because we want it to be the wall. Anyway, now, as you can see, the second parameter is the min distance to edge. So we can give this as a parameter over there, like public float min edge distance, and we can set it maybe to 0.3. There you go. We can set it as a parameter for the second variable. Then it needs, as you can see, a label filter. Basically, it will tell you which are the labels where we can generate the position. So for this, we are going to go at the top and we are going to add after the mid edge a public MRUK ensure dot scene label that we can call spawn label. There you go. Now over there we can do label filter dot included and then give our spawn labels parameters. Beautiful. And now as you can see, yeah, let me scroll down so that you can see everything. The two last parameters are simply the output, so the position and the normal. So let's do out vector3 pose and then out vector3 norm. And as you can see, with this simple line of code, we are able to generate a random position on the surface, which is super cool. And now from this, we can actually use the position and the normal to kind of spawn behind the wall. So if we do, for example, let me simply do random position normal offsets. And what we can do is, instead of using this, we want to write the pose that is output and then do plus norm. So the normal of the surface multiplied by a certain offset. So let's write it at the top. Public float normal offset. There you go. And we can write it over there. Normal offset. Beautiful. Now that we get a random position, we can set the height to be 0 as well, which will be handy. And then we can use this random position normal offset as the second parameters, and everything should be great like this. So let's find out how this works by saving and going back to Unity. There you go. Now for the spawn label, we want the spawning to occur on the wall. So let's select only the wall face, but of course you could select any surface that you want the ghost to spawn on here. And now right there, if we click on play, let me select the bedroom so that you can see the shape of the room. And as you can see, it works. We are able to generate a random position on the different wall of our scene, which is awesome, but that's not it. So let's leave play mode. And what I'm going to do is set the normal offset to maybe -1. This way, this means that the ghost will spawn 1 meter behind the wall. So let's click on play to find out if this works. There you go. And as you can see, it works. We are correctly spawning all of the ghosts outside of here, the scene model, which is exactly what we are looking for. Okay, so right now we kind of have a big issue with our ghost spawning, which is not always seen, but we are here generating a random position outside of our player environment. But what if we are not able to find this random position with the setting that we've set? And this is a big issue, right? And so let me show you how we can easily fix it. So if we leave play mode and that we go back to our script, now as you can see, this generate random position on surface return a Boolean value. And this boolean is true if we are able to find a random position with these settings or not. So what we can do is write bool as found position equals to room.generate. Now, if we indeed have found the position, then in this case, we can do what we've done before. But what if we haven't found anything, right? This means that we won't be able to instantiate or prefab, so this would be a big issue because we kind of need to spawn something. So instead, what we can do to fix this issue is give a certain number of try. So if we go at the top and that I write public int spawn try, we can maybe set it initially to 1000, which seems big, but it should never get to this kind of number. Now, anyway, what we can do is at the top, when we spawn the ghost, we can do int current try and set it to 0. And what we can do is then while current try is less than spawn try, then in this case, we want to still generate the room. And if we have found a position, there we go, we can instantiate and everything is nice. And we can even return at the end so that we stop this while loop. But if not, we can simply increase the number of try by doing current try plus plus. So I know that this is maybe a weird logic right there, but keep track that maybe the as found position doesn't work. So what we need is to have a certain number of try before we fail so that it will work most of the times and will reduce the amount of error that we can get. This is why we are doing this while loop here that will keep generating position until we have found a good one. But anyway, with this, we should have a very strong spawning system. Now, as you can see, there were two important things. First, the generate random position, and then using a system of spawn trials to make sure that we are able to find a random position. Now, anyway, let's save, go back to Unity, and let's build and run our game to find out if this works. And there you go, guys. As you can see, the ghost now correctly spawned behind the wall of the players randomly, using the little ghost spawner script that we made. This video was super fun to make with some things that I don't show a lot in my other video, like 3D modeling and making shaders, so I hope you enjoyed it. In the next episode, we will learn how to navigate our ghost in the player environment to avoid obstacles, so you better subscribe to not miss it. Thank you so much for watching and see you in the next one. Hello, beautiful XR developer, and welcome to the third part of this tutorial series where we are building a mixed reality game for the MetaQuest inside Unity. Now, after making and spawning the ghost in the previous episode, in this video we are going to learn how we can use a Navmesh in mixed reality to move our ghost to the player's position. But in the next episode we will do our core gameplay by spawning some orbs in the scene that the ghost will want to eat, and that we can protect by shooting the ghost with our ray. So make sure to subscribe and like this video. Now, as always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. But without further ado, let's get started with our tutorial. Okay guys, so we are back where we were left at the end of last episode. So right now, if I click on play, this is what's going on. We have ghosts spawning, but they are staying still. And so what we want is have the ghost move and chase after something. And this is what I'm going to show you using a Navmesh. So as you probably already know, a Navmesh is an artificial intelligence feature by Unity, which will do some pathfinding to move something to a target destination. Now, typically, if you wanted to add Navmesh inside your project, you should first go to Windows, Package Manager, and you should install here the AI navigation package that should already be there in your project if you've downloaded the MetaXR all-in-one SDK. So now let's close this Windows. And the next step to create a Navmesh is first to right-click, create empty. We can call this one Navmesh surface. We can recenter the position to 000 and add as a component a Navmesh surface. Beautiful. So this is the component right there. But as you can see, it doesn't contain any data. So the Navmesh data, so the walkable area for the agent. So to create a Navmesh data, what you can do is right click, 3D object. Let's create, for example, a plane like so. We can even scaling up a little bit. And there, if I go back to the Navmesh surface, there we have some settings to collect all of the objects that we want to use as Navmesh. For example, for the use geometry, we can instead select it to physics colliders. And for the object collection, as you can see, all the game objects will be gathered, which is not good. So instead, I'm going to select the plane and add as a component a Navmesh modifier. Beautiful. And there on the Navmesh modifier, what you can do is override the area to say if you can actually walk on this surface or that you cannot walk on it. So let's leave it like this. Go back to the Navmesh surface. And for the collect object, let's set it to Navmesh modifier component only so that it will take count only of the plane that has this component. Now, anyway, if we click on baked, this is what you should see. As you can see, a Navmesh surface has been currently set for our game, which is the blue area, which took as a data the plane mesh collider over there that has the Navmesh modifier. Now, if we wanted to go a bit further than this, for example, create some obstacle, we could right click, 3D object, cube, there you go, and we can change the size of this cube, and on this cube we can do the same, which is add a Navmesh modifier, and this time if we wanted to have this cube be an obstacle, we could set the override area to not walkable. Now, if we go back to the Navmesh surface, click on bake, this is what you should see. As you can see, the Navmesh surface is avoiding now our cube. And so this is the traditional way that you can create some Navmesh surface that will be used by the Navmesh to move around. Okay, so this is for pre-baked Navmesh, but how do we create Navmesh at runtime? Because our scene model is being created at runtime itself. And then the second question is, how do you add a Navmesh modifier and a collider to a scene model element? Now, I'm going to show you this in a minute, but first I want to show you how we can use already this Navmesh surface to make the ghost move. Oh, and by the way, I've noticed here that for the plane, the position is not set to 0, 0, 0 on all axes. Same goes for the y-axis of the cube. Perfect. So let me get back my Navmesh surface and rebake. There you go. This is because I really want here this plane to be at the floor position. Now, anyway, let's move our ghost using this surface. If we go to our ghost spawner, we can see that the prefab that we are spawning for the ghost is this one. So let's select it over there. Beautiful. So this is the ghost prefab that we are using. We can double click on it to go into prefab mode. And so what I'm going to do is add two things. First, a ghost component. There we go. That we can create as a new script. And then we are going to add a Navmesh agent. So as you can see, the Navmesh agent is like a collider. And the Navmesh agent component goal is to move here this little ghost using the Navmesh surface. Now, as you can see, the shape is not good, it seems. If you go down below, there is some obstacle avoidance settings that you can do. So what I'm going to do is actually reduce a little bit the radius, like so. I'm going to reduce also the height to something like this. 1 meter seems good enough. And actually, you can see that my little ghost with its little eyes are set on the floor position. So what I'm going to do is actually select these two. Press on W to have the move key. If we go here at the top, we can set the pivot to be global. And we can increase a little bit the ghost so that if we select the parent, this is what you should see. We can even maybe increase it a little bit higher. There you go. So this seems a bit nicer like this. This way we will have the ghost parent, which will be at the base. And as you can see with this configuration, the radius and the height seem as good to avoid the obstacle. Now, by the way, you can see that the agent type is set to humanoid. Actually, if you click on Open Agent Settings, you can see that there is a bunch of components to set for the movement of the agent. For example, the step height, the max slope, and stuff like this, which you can edit over there. Now, by the way, if we close these windows and go back to the prefab here, let's double click on the Go script so that we will be able to edit it. So the Go script will be very, very, very simple. So at the top, we can write using Unity Engine.ai. This will allow us to get the Navmesh agent. So if we write public Navmesh agent, beautiful, we can get the components. I'm also going to add a public float for the speed that we can set initially to 1. And there you go. Now on the update function, what we can do is actually get a target position. Now this is something that we will change afterwards in the next episode, because we want the ghost to target one of the orb that we will spawn in our scene. But just to debug right now, what I'm going to do is set the target position to be camera.main.transform.position. So here, as the name suggests, the camera.main.transform.position will give you the position of the main camera. And if you don't know, let me click here. And the main camera is actually the camera that has here this little tag right there. So basically, this will make sure that the target position is your head, in other words. So let's set the destination of the agent using agent.setDestination and use here the target position. We can also set the agent.speed to be the speed that we have as a parameter. And now everything should be good already. With this, we are able to set the destination of the agent, which should avoid the obstacle and use the Navmesh surface. So let's save and go back to Unity. Okay, here you go. So don't forget to drag here the Navmesh agent to the agent over there. And now one thing to do, and it is to click on play to find out if the ghost will be able to move here using the Navmesh surface, but also to set its destination to the players. And there you go, guys. As you can see, it is working. The ghosts are spawning and they are moving to the player's eyes, which is right there. So it means that everything is working and that we are now able to make the ghost move. But of course, right now, the big issue is that, well, the Navmesh surface that we are using right there is not following the player's real environment. So let me answer two big questions. First, how do we create a Navmesh at runtime? And then, how do we use it for our scene model? So let me show you. Okay, so basically the thing that we want to do is add a Navmesh modifier right there to some element of the scene model. Now anyway, let me select here our little cube and delete it because we don't need it. I'm going to actually keep here the plane because I will need it. But anyway, if we go to the Navmesh surface, I'm going to click on add component and add an anchor prefab spawner. Now, as the name suggests, the anchor prefab spawner will spawn a prefab for a certain type of anchor. Now, as you can see, this is way more precise than what's possible with the effect mesh. Now, the effect mesh will spawn a cube or a quad for each anchor of the player scene model and will assign to the mesh here this material right there. But the big difference with here the anchor prefab spawner is that if I click on the plus button, I can say which prefab I want to spawn for a specific label. So for example, if I right click, go to create empty, I'm going to call this one obstacle box. Beautiful. We can then right click, go to 3D object and then to cube. Beautiful. And now I'm going to click on add component and add a Navmesh modifier. Beautiful. Now, as you probably guessed it, we are going to use this as an obstacle. So on the override area, I'm going to set it to not walkable. Now here, make sure that the obstacle box position is at 0, 0, 0. Beautiful. And we are going to drag this obstacle box in our project folder to turn it into a prefab. Now we can select the one in our scene, remove it with the delete button, go to Navmesh surface. And so here for the prefab, I'm going to click on the plus button and drag here the obstacle box that we just created. And now what's left is to simply set the label that we want to use to spawn this box. So in my case, I'm going to spawn one for the table, the couch. We can do one also for other storage, bed, screen, lamp, plant. Beautiful. So everything that's basically an obstacle. Now let me save. And let's find out how this works if I click on play. And there you go. This is what you should see. As you can see, this is my room with all of my table. This is my computer desk and this is a storage box. And if I click on it, you can see that for here, this anchor from the scene model with the anchor prefab spawner, we have actually spawned an obstacle box that has been updated with the appropriate scale and position. And as you can see here, our Navmesh modifier is over there. This answers one of the two questions. With this, we are able to add Navmesh modifier to a certain element of the scene model. Now, if you wanted, for example, to not create an obstacle box, but to create a walkable box, you could just duplicate the prefab over there and set the Navmesh modifier to walkable. And I'm going to show you this as an exercise at the end of this tutorial. Now let me answer to you the second question, which is how do we bake a Navmesh at runtime? So for this, let's first clear the Navmesh data that we have here by clicking over there. And I'm going to click on add component and add a runtime Navmesh builder component. There we go. If we double click on the script to open it, you will see this script is very easy as well. We can simply write using unityengine.ai. Then we need another namespace, this time using a unity.ai.navigation. Beautiful. And now at the top, what we need is a reference to the private Navmesh surface that we have, that we can call Navmesh surface. So I can set this component at the start by going get component Navmesh surface. And then to build a Navmesh surface, it is very simple. We can simply do Navmesh surface dot build Navmesh. As simple as this. But there is a big issue if we do this right there, is that, of course, the scene model has not launched sometimes. So what we need is actually to wait for the scene model to be initialized by doing mruk. Oh, and let me write using meta.xr.mrutilitykit at the top, and let's do mruk.instance.register scene loaded callback. And what we can do is add a public void function called build navmesh. There you go. We can copy this function over there and simply do on this function the navmesh surface dot build navmesh call. And there you go. This way we will still wait for the scene loading to occur. And after it has been loaded, we will build our Navmesh so that everything will be nice. So let's save, go back to Unity. And now let's find out if we are able to build the Navmesh at runtime from the script. So let's click on play. And there you go. These things are turned blue, which means that we have been able to build a Navmesh. And as you can see, we can even see the Navmesh data over there, which has been built. But there is an issue. And the issue is that if we click on one of the cube, we can see that the cube has a Navmesh modifier, but the Navmesh modifier has not been taken into account. And if I leave play mode, this is just simply because there is a little issue in the order of script over there. So it's because the runtime Navmesh builder is being called before the anchor prefab spawner, which is a big problem. But we have a solution to make sure that it is not the case. If we double click on the runtime Navmesh builder, what I'm going to do is instead of void, write IEnumerator, beautiful, and right here for the build Navmesh, rename it to build Navmesh routine. And what we can do is write yield return new wait for end of frame, beautiful. And if instead we write a public void build Navmesh function that will call the start coroutine build Navmesh routine. So by doing this, we are actually, instead of directly building the Navmesh, we are actually calling a coroutine, which will first wait for the end of the frame, and then at the end of the frame, we will build our beautiful Navmesh. And this way we'll make sure that first the anchor are spawning before we build our Navmesh. And there you go, if we click on play, as you can see, it is working. We have a beautiful Navmesh surface. And as you can see, all of the little furnitures of the room are being taken into account. And you can see that the ghosts are avoiding them, which is awesome. Now, there are some improvements that we can do, of course. The first one is that here you can see that for the plane, I don't want the mesh renderer to show, so I'm going to disable it. There you go. Same goes for the obstacles. So let me go to Navmesh surface, click on the obstacle box. What we can do is simply disable the mesh renderer, beautiful, and go back to Unity. Now, if I click on play, there you go. As you can see, the Navmesh surface is updated, but there is no more cube model, which is what we want, of course, the real one in our real world. But maybe also another improvement is that maybe the area around here, each obstacle is a bit too big. So what you can actually do is leave play mode. And here on the agent type, we can go to open agent settings. and maybe reduce the radius to 0.1. There we go. So that if we leave and that we click on play, there you go. As you can see, the contour is a bit smaller, which leaves some places for the ghost to pass between two furnitures, for example. And there you go, this sums up, or you can create an awesome Navmesh surface that works at runtime for our scene model. As you can see, this works really, really great. And by the way, as promised, I want to show you that instead of an obstacle box that we have here, we can, for example, create a walkable box by simply select it and pressing on Ctrl D. I'm going to rename it walkable box. Beautiful. We can double click on it, select the cube, and here we can set the area type to walkable. And then if we go back to the Navmesh surface, here you can actually replace the obstacle box by the walkable box, or customize here all of the prefab to spawn with different labels that you want. But there is something more to tell you here, because of course the obstacle box works great for a plant, a storage, but it doesn't work for the floor or the ceiling, which are flat area. So what you can actually do, let me show you. If I select the walkable box, I can duplicate it, and instead I'm going to call it walkable quad. And then if I double click on it, I can simply select the cube here and set the Z value to 0.001. And as you can see, this flattens out everything, so that's perfect. So let's go back, select our Navmesh surface, and just as an example, if I click on the plus button, I can drag here the walkable quad instead of the obstacle box. And for the labels, I'm going to set everything to nothing and then just set it to floor. And now if I click on play, there you go. As you can see, for our floor, this has added here the walkable quad, which has taken the good size for our room. So this means that in the case that you don't want the ghost to walk on all of this surface, you can actually simply disable it. And because we've added here a walkable quad for the floor, this will make the surface of the Navmesh take into account the floor of the players. So let me click on play. And there you go. As you can see that in this example, because we've removed here the plane that was a bit bigger, we have now created a Navmesh surface area with just the floor of the player that avoids all of the different furniture that we have. Okay, so let's leave play mode, and this was just a little example for you. Now in my case, I'm going to remove this one, the floor, and re-enable the plane, because I still want the ghost to walk behind the wall of the player and enters the room through the wall. And there you go, this concludes our tutorial. At this point, you can simply build and run, and this is what you should see. And there you go guys, this is already so much fun. We can play hide and seek with the little ghost that we made. Now I hope that you enjoy watching this tutorial and that you are ready for the next one. Big shout out to the new Patreon, which will appear soon on the screen. If like them, you want to get access to the source code of this game and other exclusive content, join us, link in the description. Thank you for watching and see you soon. Bye bye. Congratulations, you have found the most important video of this tutorial series where we are building a mixed reality game from scratch for the meta quest in Unity. Now, after using Navmesh to make the ghost move to the player's position, in this episode we will do the whole gameplay by spawning some orbs in the scene that the ghost will chase and eat, and that you will be able to protect by shooting the ghost with the ray. In the next one, we will learn how we can customize the path-through and use a stencil effect to make this cool flashlight that will reveal the ghost. So if you haven't already, make sure to subscribe and like this video to not miss it. As always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content, and of course. But without further ado, let's get started. Okay, so we are back where we were left at the end of last episode, and now we have a lot of work for today's tutorial. So first we need to kill the ghost with the gun, then we need to spawn the orbs, then make the ghost find the closest orb to eat them, and finally trigger a game over if there is no more orbs on the scene. So first, if we go to the asset, then you can see the ghost that we made in the previous episode. If I double click on it, we can go into prefab mode. And what I'd like to do is create a death animation for the ghost that we will be able to trigger when we hit the ghost with the ray. So for this, I'm going to click on Add Component and add an animator. Perfect. Once created, you can go to the animation tab over there, which you can open by clicking on the three little dots, Add tab, and then click on Animation. Beautiful. When it is done, we can click here on create, and I'm going to call this one Go Death. Beautiful. Now for the death animation, I'm going to click here to start recording and then go into the ghost model that we have. And what we can do is actually change here the material value. So for the initial color, I'm going to right click, copy. We can just change the color, and as you can see, this has created a key for the animation that will be used for the start value of the color. Then I can close this window, pass back the value that we copied at first. So this means that we will start with this initial value. And then I can move here the animation a bit later, let's say a tenth of a second. And I'm going to change the color to something red, like so. Beautiful. And already if we go from the first to the second keyframe, you can see the animation playing, which is already looking great. So then I'm going to go on to the next keyframe at a tenth of a second later. And what I like to do is here change the alpha value and set it to 0. This will make our ghost fade away when we shoot at it. And there you go, this is the result animation that we have. So first we get from the initial color and we lerp to a reddish color, and then it just fade away. And this is at this moment that we can destroy our ghost. Okay, so now that we've created the animation, let's click here to disable the recording mode. We can even disable the preview. And now if I go to the parent, we can see here our animator, which has a ghost controller animator. So if we go to the animator tab, which you can open if you go to Windows, Animation, and then Animator. So here, as you can see, by default, we have the ghost death animation, which is playing. It means that if I click on play, it will directly play the ghost death animation, which is not what we want. So instead, I'm going to create an empty state like so, which we can set as a layer by default state. And now to trigger the ghost death animation, what we can do is right click and make a transition to the ghost death like so. And we can control the transition with, for example, a trigger parameter. So if you click on parameters over there, we can click on the plus button and add a trigger here, which I will call death. Beautiful. And now on the animation, if we go to settings, for the condition, we can click on the plus button. And here, as you can see, it has directly set death trigger to be the condition to go from the new state to the ghost death animation. Oh, and also make sure to disable here the has exit time. This will make sure that it will not wait to trigger the ghost death animation. Now, anyway, we can save, go back to the scene. We can click here to leave the prefab editing tool. And now our goal is to call this death animation from the ray gun if we hit a ghost with the gun. So if you remember, if I go under the right and ensure, this is where our ray gun is, with here the ray gun script that we made in the first episode. So let's double click on it to open it and be able to edit. Okay, so if you remember, this is the function that shoots a ray and which will actually call a ray cast. And if we hit something, we will spawn a ray impact, and otherwise we will just give a default value to the end position. If we hit something, we want to make sure that it is either a ghost and that we play the death animation, or if it's not a ghost, we can just do what we've done before, which is spawn an impact. So to do so, I'm going to get the ghost script from the hit point with it.transform.getComponent in parent, and the component we want is the ghost component. So in the case that there is a ghost and that there is this ghost component, what we can do is simply kill the ghost over there by calling the ghost.kill function. And otherwise, we simply need to do as we've done before, which is instantiate a ray impact. Okay, so at this point we have two use cases, one where our ray gun finds a ghost and another where it finds something that is not a ghost. And at this point we need to call here a kill function on the ghost that will be able to animate our ghost and then to destroy it. So for this, let's simply press on the control key and click over there on the ghost component to directly go in the script to add this function. And now I'm going to call a public void function called kill. Beautiful. Now on the kill function, what we can do is first we can disable the agent, which means that the ghost will stop moving. And by the way, in the update function, we can first check that if there is not agent enabled, we can simply return. And now I'm going to go at the top and add a public animator reference to the animator that we have created just before, and simply do animator.setTrigger and use here the death trigger name that we've used. And beautiful, by calling this function, we are disabling the agent and then triggering the animation. So what's left is to go back to the Raygun and simply do ghost.kill. Beautiful. There we go. Now we can save and go back to Unity. Now there is nothing to set up for the Raygun, but if we go to our ghost, you can see that on the ghost script, we are missing a reference to the animator. So make sure to drag it over there. Beautiful. Oh, and something very important also that I've forgotten is that if you go to the ghost animation that we just made, make sure here to uncheck the loop time, otherwise the animation will keep on looping every time, which is not good. So anyway, let's save now and click on play to find out if this is working. Okay, so right now there would be some bugs by shooting the ghost, because if we double click on it, you can see that we have here a Navmesh agent, and on the child we have no collider except the one that is sitting here on the eyes, which is something we don't want. So let me go on the quad and remove this component, and instead I'm going to go on the ghost and add a capsule collider. Beautiful. Now if I change the height, you can see that the collider is oriented along the y-axis. Let's change it to the z-axis instead, and we can maybe tweak here the height and the radius of the capsule to have something that feels nice. Beautiful. So now we have actually created the capsule collider that the Raygun will be able to find. We can leave the prefab selection. And another bug that I want to avoid is that if you go to the ray impact, you can see that we actually left the mesh collider on the ray impact, and this is bad because it means that this will add some collision that we don't want. So let's simply right click and remove it as well. Keep a minimal number of collision. And beautiful, now everything seems to be good. Let's click on play to find out if this works. And there you go, as you can see, it works. I can actually kill the ghost and trigger their death animation. But as you can see, the eyes are still showing, which is not good because it means that we have not destroyed the ghost after the death animation. So let's go back to Unity and fix this. Beautiful. This will be very simple. We need to go, if we select our ghost prefab, there we go. We can go on the animator here and we can go into the ghost death animation. And what I'm going to do is here create an event. There we go. Now an event is a function that we can call from the animation. And now you guessed it, I'm going to go on the ghost script and I'm going to create here a public void destroy function that will simply destroy the ghost game object. Yeah, perfect. If we save and go back to Unity, there we go. Now if I click on the event that we've just created, I can go in the function, go to ghost method, and then select the destroy function, which will make sure that after the animation has played, it will destroy the ghost game object. Oh, and one more thing that we can do if we go in the Raygun, actually in the case that we have a ghost, we can even disable the ghost collider by doing it.colliders.enable equal false. This will make sure that we cannot shoot twice the ghost while it is in the death animation. Now anyway, let's save and find out if this is working. And there you go, as you can see, it is working. Now I can shoot the ghost, trigger the death animation, and the ghost is completely destroyed after playing the animation, which is what we want. Anyway, now that means that we have finished with the first part of the gameplay, which is be able to kill the ghost, but now we need to spawn some orbs that the ghost will want to chase. So for the spawning of the orbs, I'm going to do a little bit the same as we've done for the ghost, but just spawn a certain number of elements at the start of the game. So let's right click. And for the orb itself, let's simply right click in the hierarchy, go to 3D object, sphere, beautiful. This will create, as you guessed it, a sphere. And now if we right click on the assets, create material, I'm going to call this one orbs material. And what we can do is actually use the same shader that we've used for the ghost, but this time for the orbs. So let's simply drag this orbs material on the orbs. And what I'm going to do is increase the power and change maybe the color to something yellowish, like so. It looks good. Now anyway, we can give it this size and I'm going to rename it orbs. Beautiful. And we can drag it in the asset folder to turn it into a prefab. Then we can remove the one that we have in the scene and I'm going to create an empty game object that we can call orbs spawner, which we can reset its position and add as a new component a orb spawner component. As always, at the top, I want to add using meta.xr.mr utility kit namespace. Then for the parameters of the script, I'm going to write a public int called number of orbs to spawn that we can set initially to 5. Then we need a public GameObject reference to the orb prefab that we will spawn. Finally, we can add also a public float height, which will be the height of the orbs when they spawn. And now we can remove the update function, but on the start function, what we can do is call mruk.instance.register scene loaded callback. And then we can create a new function called spawn orbs that we can call inside the register scene loaded callbacks. This means that when mruk will be finished to registering the scene, we will directly spawn the orbs inside the scene that we've just registered. Okay, so to spawn the orb, let's do for and loop index that goes from 0 to the number of orbs that we want to spawn. I'm going to then create a random position that we can initialize to vector3.0. So now that we have initialized a random position, we can get the mruk room that we are with room equals mruk.instance.getCurrentRoom. Beautiful. And now with this room, if you remember, we can generate a random position on the room surface, and this is what we will do. We can first get a as found boolean and do room.generate random position on surface. Now for the parameter, the first is the surface type, and the one that I like is the floor, so let's do facing up. Then the second parameters is the minimum distance to the edge, so let's set it to 1, for example. Then it is the label filter, and in our case, because we want to spawn on the floor, let's do label filter.included mruk anchor.sceneLabels.floor. This will include the floor label for the spawning. And finally, we can output two things, the random position and the normal. So let's do out random position. So this will set the random position that we've initialized over there. And for the position normal, we can simply do out vector3n. So we won't use this value anyway. And there you go. Finally, with this random position, let's set maybe the random position.height to be the height that we've set as a parameter over there. And there you go. With this value, we can spawn a new orb by doing spawn equal instantiate, and there give as a parameter the orb prefab with the random position. And for the rotation, we don't want any, so let's do quaternion.identity. And there you go. At this point, with this function, we are able to spawn a certain number of orbs. And what would be great to do is actually gather a list of these orbs in the scene. So let's do at the top public list of game objects spawn orbs. Beautiful. And at the end, we can simply do spawn orbs.add and add the spawn one that we just did. Okay, so this is great, but of course there might be an issue with this if you remember the Go spawning episode. And the issue is that sometimes the generation of a random position on the surface is not possible. And in this case, the as found value return false. So in this case, what we want to do is actually retry again and again till we have found a position. So to fix this, what we can do is simply go at the top here and add two variables, a public int called max number of try, which we can set to 100, for example, and a private int, this time called current number of try, which we can set initially to 0. And so instead of here generating a random position only one, what we can do is do it a certain number of times until we have found a value by doing while current number of try is less than number of try. And in this case, we want to generate the random position. If we have found something, then we will break the loop. And otherwise, instead of breaking, we will simply increase the current number of try. This means that the while loop will always increase until either it breaks because it has found something, or that it has not found a random position with the max number of try that we gave him. Okay, and here we go. As I think our script is now done, we can save, go back to Unity. You probably know the next step. As you can see, the orb prefab, we can drag the orbs that we created previously over there. For the height, let's set it to maybe 1 meters, and the rest I can keep it this way. So now, as you guessed it, only one thing to do, and it is to click on play to find out if this is working. Look how cool this is. So after just loading the scene model, we have now generated 5 random positions in the scene, and we are able to spawn 5 orbs that, well, the ghost will be able to chase in a minute, because now, for now, they are just trying to chase me. So anyway, now that we've succeeded to spawn a certain number of elements in the scene, let's edit the ghost script to be able to chase one of the ghost script instead of me. Okay, so this shouldn't be that hard if we click on the ghost and that we double click on the ghost script. Here, as you remember, the target position that we gave for the agent is the position of the main camera. So instead of giving the main camera position, we want to give it the closest orbs from the ghost. So for this, let's simply do public GameObject get closest orbs. There you go. Now in this function, we can create a GameObject called closest that we can initialize to null and get a float called min distance that we can initialize to mat.infinity. And so in my case, I want to loop the list of orbs that we have. Now to easily be able to access all of the orbs, what we can do is go on the orb spawner. And as you can see, there is the spawn orbs list that actually does this. But what I'm going to do is create a public static orb spawner reference called instance. So this will be a singleton. And we can actually set on the awake function the instance to be this script. Now, because this variable is static, it means that it can be accessed from the other script directly without reference. So let's go back to the Go script. And as you can see, I can get the list of GameObjects orbs by doing orb spawner dot instance dot spawn orbs. Beautiful. Now that I've gathered the same list of orbs, we can loop them with a for each. Then we can get the distance from the ghost by doing transform.position to the orbs by doing item.transform.position. Beautiful. And if the distance that we get is less than the minimum distance that we have currently, what we can do is set the minimum distance to be the d value that we just found and set the closest GameObject to be the item that we are currently at. And there you go. Now at the end, after looping through all the orbs, we can simply return the closest GameObject that we have found, the one that will be set when its distance is less than the current minimum distance that we are calculating. Now, beautiful, this is getting good. Now what's left to do is to get the closest by doing GameObject closest equals get closest orb. And if there is a closest, this means that if there is an orb to chase, then in this case, we can set the target position to be the closest .transform.position. And there you go. Now this should do the work. Now we can save and go back to Unity to see if this is working. And there you go. Look at how cool this is. So now you can see that the ghost that is trying to chase the closest orbs from him. And this works for all of the other. Instead of trying to chase the player, now they are currently going on the correct one. For example, if I just move it, you can see that they are chasing the others, so always the one that are the closest. But right now there is two little issues. The first one is that I think the orb's height spawning is a bit too high, and then we want the ghost to be able to destroy the orb if it reaches it. So let's leave play mode and find out how we can fix this. So for the first issue, which is changing the height of the orbs, we can simply go over there, and for the height, let's set it to 0.7. And now to let the ghost eat one of the orbs, what we can do is go to the orb spawner script. And I'm going to create a new public void destroy orb. Beautiful. And on this function, what we want is to take as a parameter the orb that we want to destroy. And then we can simply remove it from the list and then destroy the GameObject itself. So now we need to call this function from the ghost script. And at the top, what I'm going to do is simply add a public float call it distance that we can set maybe to 0.3. There you go. And very simple here, if the minimum distance that we get from the orb is less than the it distance, what we can do is simply get the orb spawner instance and destroy the closest orb. And there you go. Now we can save, go back to Unity and try to see if it is working. Okay, and as you can see, this is what's going on. As you can see, it doesn't work very well. Now the answer is that we have actually made a little mistake on the way we are computing the distance, because we are actually getting the distance from the position of the ghost, which is at its feet, and it shouldn't be on its feet position. It should be at the center of the ghost. So to fix this, we can actually leave play mode. And here for checking the distance, what we can do is actually get the ghost position to be transform.position and then set the ghost position.y to be 0. And then do the same for the orb position with item.transform.position and set the orb position.y to be 0. So this way, by checking the distance from these two values instead of directly the transform.position, we are making sure that on the y-axis they have the same value, which will give us the horizontal distance and will not take the difference in height between the two. So this should be a bit better. Now let's find out by clicking on play. And there you go. Now we have the 5 orbs that are spawned. Let's find out if the ghost can eat it when it reaches the orbs. And as you can see, it works, and the ghost even goes to the next one, which is the closest to him. And as you can see, it is working. Everything seems fine. Now you can even tweak the it distance value. If you go back to the ghost, for example, in my case, I think the it distance can be good if it's set to maybe 2.2. And there you go. But of course, right now, let's see what happens if there is no more orbs. So as you can see, if the ghost have eaten all of the orb, nothing happens. So the ghost stays still, but nothing happens. So let's find out how we can trigger a game over when there is no more orbs left. Okay, so this will be very, very easy. On the destroy orb function, what we can do is check that the spawn orbs.count is equals to 0. So let's do this in an if statement. And if it's the case, it means that there are no more orbs in the scene. And in this case, we can either trigger a game over by changing, for example, the path-through color and adding a nice UI. And that might be something that we will do in the future episode. But in this case, let's simply restart the scene by doing Unity engine.scene management.scene manager.load scene and load the first scene that we are currently at. Beautiful. Now let's save. And if we click on play, and there you go, let's find out what happens when there is no more orbs. And there you go, the scene is correctly reset, which is what we want. And there you go guys, the gameplay of our mixed reality game is looking good. The orbs are now spawning, the ghosts are chasing them, we can kill the ghost, and when there is no more orb in the scene, it is game over and we are relaunching the scene. A big shout out to the new Patreon which are on the screen right now. If like them you want to get access to the source code of this game and other exclusive content, join us, the link is in the description. Thank you for watching and see you soon, bye bye. Welcome guys and congratulations if you managed to get to this part, because we are almost done with our mixed reality game that we are building in Unity. In this episode, I'm going to show you how we can customize the path-through by changing the color, projecting it on the surface, and even using multiple path-through to create this awesome flashlight effect. But I'm not done, because we are then going to learn how to reveal our ghost through our flashlight using a stencil shader. Now in the next video, I'm going to show you how we can publish this game in the official meta store, so make sure to subscribe to not miss it. As always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. Okay, and here we go, let's get started with the flashlight effect that you saw in the introduction of these videos, and that will teach you a lot about customizing the path-through. But of course, for this flashlight effect, we need a flashlight 3D model, and lucky for me, I found this nice looking one on the asset store that you will be able to download with the link you will find in the description. Now after logging, we can simply click here on open in Unity, open Unity editor to open here the package manager with this asset. We can then click on import to import it on this project. And here is everything that the package contains. We can then click on import to add everything. Beautiful. Now we can close this window, and as you can see, we have this new folder that is showing now in this project, and that will contain the flashlight asset. If we go to flashlight gold, we can see here the flashlight over there, but there is a big issue. And of course, the big issue is that everything is pink. The reason is that all of these shaders are using the standard pipeline and not the universal rendering pipeline like we are using for this project. But worry no more, because it's very easy to fix this. Let's first click on the flashlight folder over there, then click here on material, and here for the search, let's search for everything that is inside the flashlight. This will, as you guessed it, select all of the material that are under here the flashlight folders. And now what's left is to select them all by pressing on the caps key, and then go to edit, rendering, materials, convert selected built-in materials to URP, and then proceed. And as you can see, by doing this, we have changed the shader of all of the materials, and this actually kept the same texture as before. So one thing left, and it is to reset here the search, go to the flashlight goal, and drag here the flashlight prefab inside the hierarchy. And as you can see, we can see our beautiful flashlight over there. Now, as you can see on the children of this flashlight, we have a white light, which is just a spotlight that will show some light in the forward direction of the flashlight for a nice effect. And as you can see, there is also a cookie which will show here this pattern on the surface that the light hits. Now anyway, what we want is for the flashlight to follow our left hand, so I'm going to go under the camera rig and drag the flashlight as the child of the left hand encore. Beautiful, but you can see that the flashlight is on the opposite direction. So let's simply press on E, then while pressing on the control key, I will rotate 180 degrees. And this is the final result for the rotation. And as you can see, it is pointing here the flashlight in this direction. I'm also going to move the flashlight a little bit forward. And now everything should be good. Let's save and click on play to find out how this is looking. And there you go, this is what you should see. As you can see, the flashlight is now following my left hand. And it is looking real nice with here on the right hand the ray gun. I can even do this to light up the ray gun. But now it is time to show you what we can do with the path-through. Now the issue in my case is that because I'm recording here right now, the path-through is not displayed within the Unity editor. So what I'm going to do for you to see the path-through is to cast my device directly using the oculus.com/casting website. Now anyway, if I go back to Unity, there, if you remember, we added a path-through for our game in the first episode with here these building blocks that contain the OVR path-through layer. But what I didn't told you at the time, there are settings to tweak here the look of the path-through. For example, with here the color control. So let me show you what it looks like if I click on play. There you go, this is what I can see. But if I take here the OVR path-through layer, you can see that with the color control, I can change, for example, the color control to color adjustment. And look at what happens. We can change the contrast, the brightness, but also the saturation. And there are so much more than the color adjustment. As you can see, there is the grayscale color, the color LUT, and the blender color LUT. Now, anyway, this is just to show you how we can tweak here the look of the path-through. As you can see, to have this kind of result. You can even click here to have edge rendering, which will, as you can see, add some edges to the path-through. Now, anyway, in my case, I'm going to remove here the edge rendering. Maybe set the brightness to this value and then copy this component. And now we can leave play mode to go back to the path-through, right click and paste back the component value that we saved during playtime. And this way we are able now to customize the look of the path-through using the color control and the edge rendering. But that's not all, because as you can see, we have also another setting here called the projection surface. Now by default it is set to reconstructed, which means that it will be displayed around a big sphere around the player. But what if we wanted to display this path-through only on one particular mesh? And this is what I'm going to do with the flashlight currently. For example, here I have the flashlight and I'm going to search for cone. Here I'm setting it to everything. You should see here this cone 3D mesh that is within the Meta XR SDK package. Now we can simply drag it as a child of the flashlight. And here it is, we can see it. Maybe we can rotate it 180 degrees and place it in front of the flashlight, like so. There you go, this seems good. We can maybe increase a little bit the size and change everything how we want. There you go, this looks nice. And as you guessed it, we are going to use the mesh of this cone for the path-through. And this is very simple to do. We can simply go to the path-through, and here instead of reconstructed, let's set it to user-defined. And as you can see, we have here the projection surface that we can set for this path-through, which instead of displaying the path-through to a whole sphere, will display the path-through on one particular object. So let's click on the plus button, drag the mesh model that contains the mesh filter over there. And because we are updating the transform, let's set here the update transform. Now in our case, we want to display the path-through, so we don't want to show here the mesh renderer material. So let's simply go to the mesh 1 model under the cone and disable the mesh renderer. And now by doing this, we should be able to show the path-through only through this cone following our flashlight. And there you go. As you can see, it is working. The path-through is only showing through the flashlight that is over here. And I really like this effect already. As you can see, in a matter of a few seconds, we were able to just tweak the surface that we are using to show the path-through. So after changing the color of the path-through, we are now able to project it on a custom surface. But what about the rest? What if we still wanted to display another path-through where the flashlight is not showing? And this is what's possible with the composition depth. So if we select our path-through over there, what we can do is simply rename it path-through flashlight, and then duplicate it with Ctrl D. We can even remove the building blocks over there, remove the building blocks component here, and rename this one path-through background. There you go. And now in this case, we want to set the projection surface to reconstructed to be displayed around the player. And for the color, what I like to do is instead of 0.2, we can set it to -0.2. Same goes for the saturation. And we can even reduce a little bit the opacity to turn this path-through a bit more darker than the other one. And there you go. Now at this point, we have two path-through. We have one path-through that will be projected on the cone following the flashlight model, and another path-through that will surround the player. But how can we know the order between these two path-through? Which one of these two should be displayed in front? And this, we can tweak it with here the composition depth. So as you can see, the smaller number will appear in front. So in our case, what we want to do is set the path-through background to 1. This way, the path-through for the flashlight will be less because it has a value of 0. And this means that the path-through from the flashlight will always be displayed in front. Now everything should be ready. Let's find out if this works by clicking on play. And there you go, guys. Look at how cool this effect is. As you can see, the flashlight is working. And within the cone of the flashlight, we are displaying a bright path-through. But outside of it, we are displaying a darker one. I really think this effect looks really nice. But look at what's happening right now. We have still the ghost showing anyway. So I think a nice touch that we can do is also only display the ghosts where they are shown through the flashlight. Okay guys, so we already made one cool effect with this flashlight, but right now with this flashlight, except of this cool effect, we are not doing much. So I think it would be really nice if we could only reveal the ghosts where they are shown through the flashlight. So let's find out how we can make this effect. Now anyway, you might probably already know how to make this effect from my tutorial on how to make a path-through, and it is using a stencil shader. So if you want to get more information about how a stencil shader works, go watch that video first. But anyway, let's get started on making our reveal effect. Now, if we go to the settings, you should see here some URP settings. These URP settings are used if we go to Edit, Project Settings, and then if you go here to Graphics, you should see here that the URP High Fidelity is being used currently. So what we can do is, let me just resize this window a little bit. If we highlight it, it will show you where it is in the project, so we can click on it. Now you can see that this URP High Fidelity is using for the renderer list, this renderer, and this is actually the item it is showing. Now here the high fidelity renderer is where we can create our stencil effect. Now by the way, if you have here the screen space ambient occlusion, it is really bad for VR, so let's simply disable it. It will be much better. Now anyway, for the stencil effects, let me go to the prefab. Then we can drag here our ghost over there in the scene and we can move it maybe in front of the cone. Beautiful. Now the secret is to first set the ghost to a new layer. So let's click here and then on add layer, we can call this one ghost. Beautiful. We can go back to the ghost layer and set the layer to ghost. And we want to change the children. So let's say yes. Okay, now that we've changed the layer to ghost, what we can do is go to the high fidelity renderer. And now for the opaque layer, we can remove the ghost. There we go, let's do this the same for the transparent layer. And as you can see, our ghost has disappeared, of course, because it is not part of the filtering right there. But don't worry, because we are going to add it back within the renderer feature. So let's click on add renderer features, render objects. We can rename this one stencil opaque 1, beautiful. We can set the event after rendering the opaque. For the queue, let's set it to opaque. For the layer mask, let's use our ghost. And then we can use a stencil by clicking over there. For the value, I'm going to set it to 1. There you go. Now for the compare function, what we want to do is set the compare to equals. And we can keep the rest like this. Now this is for the stencil opaque. But as you can see, it has done nothing on our ghost because our ghost is still not showing. And this is because our ghost is transparent. So let's fix this by doing this as well for a transparent layer. So let's click on add renderer features. Render object. Let's rename it stencil transparent 1. Let's set the queue to transparent. After rendering the transparent, let's rewrite the stencil, set it to 1 like before, and set the compare value to equal. And of course, I forgot to set here the layer mask to then ghost. But as you can see, our ghost is still not showing because if I, for example, change the compare function to not equal, you can see that now it appears. And because we are setting here the compare function to equals, it means that the ghost will only appear when it is being shown through another stencil that has a value of 1. So at this point, the only thing that is remaining is to create another stencil that has a value of 1, and you guessed it, we will assign it here to our flashlight. So if we go to our flashlight, we can go as a child that we still have here. If I re-enable the mesh renderer, we can still see it over there. But right now, the mesh renderer is using a default material, which has no stencil value. So this is not good because it won't make our ghost appear. Now, instead, what I'm going to do is use here a custom shader that I made, which is called the Valem tutorial stencil. Now, if I double click on it, you can see that this shader is super short. And basically the only thing that it does is, as you can see, write a certain stencil value. Now, anyway, you will be able to find this shader in the file under this video, in the description down below. And what I'm going to do is actually right click on the asset, create material. I'm going to set this one stencil mask 1. And what we can do is change this shader by searching to stencil. And here is the stencil that we want, the Valem tutorial shader. There you go. Now we can simply go back to our cone, drag the stencil mask over there, and as you can see, it has turned the material to transparent because it is doing nothing more than writing some stencil value. But as you can see, the ghost is still not appearing, and the reason is that the stencil ID is set to 0 here. But watch what happens when I set it not to 0 but to 1. Our ghost is now showing, and as you can see, the effect is working because if I take the flashlight parent and that I try to move it, you can see that it actually revealed the ghost, which is looking really great, and this is going to be awesome in mixed reality. Now anyway, before finishing everything, what you want is to override here the ghost and click on apply all. This will make sure to apply the layer ghost to the prefab. We can now select it and press on the delete key to remove it. But there is still one issue before we can finally test our game, and it is that if we go to our raygun, you can see that the layer mask of the raygun is set to default, which means that it will only collide with the default layer. and which means that we won't be able to shoot our ghost anymore. So make sure here to add as well the ghost in this list. And there you go. Now one thing to do, and it is to build our game to find out how it is working. Oh, and okay, as you can see, our effect is not working at all. So let me show you how we can actually fix this problem in Unity once and for all. Now anyway, if we go back to Unity and that we go to Edit, Project Settings, there, not in the graphics but on the quality, we can see the issue. The issue is that we have multiple quality levels. This means that in some cases, instead of using the high fidelity renderer that is currently over there, it will use another one. But we have made this all high fidelity renderer effect with the stencil opaque and transparent for the high fidelity and not for the other. So let's simply remove here the performant and the balance one to only keep the high fidelity renderer that we used. And now anyway, let's close this windows. And with this problem fixed, everything should be working now. And there you go guys, look at how cool the flashlight effect is looking in mixed reality. And now that we can only reveal the ghost through the flashlight, this is actually changing everything. The game is so much more challenging. Now anyway, I hope you enjoyed this tutorial and that you are ready for the next one. In this video, I'm going to show you the complete step-by-step process of publishing your VR or XR game to the official MetaQuest store. Now in the first part, I'm going to show you the unit setting that you need to do to create a store-compatible APK. Then we will learn how to add this APK to a release channel with the MetaQuest Developer Hub. And finally, create the store page. Okay, so if you are building your mixed reality game like mine within Unity, there are some settings that we want to make sure first before we build an APK that we want to send to the Meta Store. Now, first thing first, make sure to go to Edit, then to Project Settings. You should see this window showing right there, and you should maybe see here the Meta XR page if you are using the Meta XR SDK, like it is the case for this project. The good thing with the Meta XR SDK is that, as you can see, you have here a list of all of the settings that you need to do to make sure that your project is set up correctly. And the good news is that if you have already done all of this setting, there is not much to do from this point on. But in the case that you are not using the Meta XR SDK, so for example the Unity XR toolkit, let me show you what you need to do. So if we go to Player, the first thing that we want to make sure is to go here and change the company name to, well, our company name. In my case, I'm going to name this Valem Tutorials. For the product name, we can keep it to Ghost Hunter. Okay, so for the default icon that we can see here and that we can set over there, we can just ignore it. But if we go to resolution and presentation, there is just not much to do this because we're making a VR game. Now, anyway, for the splash image, this is where you can, for example, remove the Unity logo in the most recent version of Unity, or if you have a paid subscription. Next, if we go to other settings, this is where things get interesting. So if it's not the case, make sure that all of your settings are a bit the same as mine right now. And this starts here with the color space that needs to be set to linear. For the graphics API, here in my case, I have both Vulkan and OpenGLES3. And I'm going to remove this one as Vulkan is a bit more optimized and is now allowed on the Metastore. There you go. If we go down below, the texture compression is set to ASTC, which is good. And they're very important for the identification. Make sure that the package name is a custom package name like this. And it should be good if it would be actually the same as for here the company name with the product name. So I'm actually going to write Valem Tutorials here instead of Valem so that it is a bit the same as the value on the top. We can leave the version and the bundle version code to 1. And for the target API level, I'm going to set it to 32. Beautiful. There you go. So down below, make sure that only the ARM64 is enabled. And for the write permission, let's set it to internal. And there you go. These are mostly the settings that you need to make sure you've handled. Now for the rest, it is not very important. So let's move to the last publishing settings. And here there is a very important thing to do before we build our game, and it is to create a key store. So I'm going to click here on Key Store Manager. This will open this window, and if we click here, we can create a new key store anywhere. And this should send you to your project. I'm going to name this one Ghost Hunter. Beautiful. We can press on enter and this will create the key store. So let's add a password to this key store and it needs to be at least 6 characters long. There you go. Now that you've entered password, you need to set an alias with another password here. It is better, of course, if you use another password than the one above. Here we can set also a validity for this key store to work. Beautiful. And now what's left is to simply click on add key. We can say yes to set this key store as our project key store. And there you go. As you can see, this has automatically created a key store for our project with here our password. Now everything is done. We can save, close this window. And the next thing that you want to make sure is the Android manifest. So if we go to plugin, then to Android, you should see this very important text file that contains some crucial information about what is allowed in your application. But at the moment here, this Android manifest is not complete. Why? Because we are using some stuff in our game that is not referenced here on this Android manifest. For example, we cannot see anywhere that we are using the pass-through for our mixed reality. We cannot see anywhere that we are using the scene model, which I'm using in this game, and which we can see if we go, in our case, to the OVR manager. So as you can see, and tracking is not supported, but we do have some pass-through over there. And we have as a permission request on startup the scene model to allow us to do some scene detection. So all of this needs to be reflected inside here, this Android manifest. So you can basically open the text file in a text editor and edit it. Or another easier way to do so is if you are using the Meta SDK, you can click on Meta, then on Tools, and then here you can click on Create Store Compatible Android Manifest and look at this 1, 2, 3. If we click on Replace, there you go. You have seen here the Android manifest change in runtime. It has, as you can see, changed all of this stuff, which is adding a permission for the pass-through, for the scene model, and for the Anchor API. And this will make sure that everything is correctly set and that our app will be allowed when we push it on the store. And there you go. From that point on, everything is ready on our settings. The project settings of our application is good. The Android manifest is good. So let's go to File, Build Settings. Make sure here that the Android platform is selected. And now we simply need to click on Build and give a name to this build. I'm going to name this one Ghost Hunter. There you go. And click on Save. And there you go. After waiting a little bit, we have our build that is made and that we will be able to push to the Meta Store. Okay, so now how do we push this beauty into the Meta Store? Let me show you. So the first thing is to go here to the developer.meta.com website. You need, of course, to create an account for yourself. And once signed in, you can click on My Apps. There you go. This will send you here to the MetaQuest dashboard that will contain all of the applications that you've previously pushed on the Asset Store. Now, as you can see, I've already done a push of this application right here to prepare this tutorial. But before doing so, you first need to create a new organization if it's not done already, which is very simple. If you go at the top, you can click here and click on Create Organization. Creating an organization is very simple. You give it just a name like My Organization Name Test. There you go. We can click on I understand, submit, agree, submit. And once you've created an organization, you need actually to verify this organization by going here to org verification. And from this point on, if you have a business, you can start the verification and add your business information over there. And then you can add yourself as an administrator of this organization by giving one of these information. Okay, so at this point, you have created an organization, you have verified this organization, and then you will have to wait 1 or 2 days for Meta to accept your verification. But when the organization is made, this is now where we can create a new application that will receive our APK. So for this, very simply, you can click on Create a New App. Then we can give a name to our application. I'm going to name mine Ghost XR. There we go. And we can say if the application is on a Quest, so if it is standalone, or if it's connected to a PC with Link PC VR here. Now in my case, because we are using an APK, we are building on the Meta Horizon store. So I'm going to click this one and then on create. And there you go. As you can see, our Ghost XR application has been created. If we click here on the dashboard, we can see our new Ghost XR app among all of the other applications. And at this point, it is time to add the APK that we just built to this application on the Meta dashboard. So how can we do so? The first thing that you will need to do is go here to this website to download the MetaQuest Developer Hub. Once downloaded, this is what you should see. So the MetaQuest Developer Hub is an awesome tool made by Meta for us developers. As you can see, there is a bunch of things that we can do with it. And one of these tools is here, the app distribution. So let's click on it. There you go. And if we select the Valem Studio organization, so the organization that I've just created, we can see our Ghost XR application that we just made. And now if we click on it, we can see here that we have 4 release channels. Now basically the release channel are some channels that we can push our app to for different parts of development. Now in my case, I'm only going to use here the production and the RC channel. Anyway, now what we can do is click on upload, navigate to where our APK is. Mine is right there, and I'm going to double click on it. And there we go. Now we can click on next. Here, as you can see, there is a bunch of settings that we can say. For example, the supported device. You can see that by default, the Quest device, which is the first Quest headset, is removed because there is no pass-through in the first Quest, which I'm using for my game. So that's why it is by default disabled. Now, anyway, I will keep everything as is and click on upload. And now this is the moment of truth. Those our APK works when we push it on the RC channel. And there you go. As you can see, after waiting just a little bit, everything seems to work. As you can see, the build has been received on the RC channel. Now, from that point on, it means that you have finally pushed a build to a channel on the Meta Store. Now, this is very useful, and I'm going to show you why. If we click there, we can click on View Build. There you go. And here we are sent back to the MetaQuest dashboard that we were just before, and we can have a look at the build that we just made. Now, as you can see, there is a little issue here because the self-certification is incomplete. So let's click here on Start to finalize everything. And I'm going to select the Teens and Adult one, then click on Continue and on Confirm. Beautiful. Now that we have a build that is on the RC channel, if we click on Release channel, we can see our RC channel over there. And as you can see, the invite method is set to email invite only. So if I click here on this channel, then if I go to user, I can invite here some user to test my game. And already this is super useful because this means that we can invite some people to test our game. Or maybe if you just simply want to test your application on different devices, now you can add yourself among the user of this channel, and on all of the devices that you are using, you will see this Ghost XR application, which means that now when you create a new version of the application, you can push it on this channel like we've done just before, and all of the devices that are invited inside this channel will receive the update automatically. So now you will not have to push every time. Okay, so one last thing that I need to mention is that if here you are making a new update on your application that you are trying to upload, so if you click here on upload, then you select the new version that you just made and then click on next, then upload. This is what you will see. We have an APK version duplicate, which is a big issue. So actually, when you are making a new version of your application, what you need to do is go to Edit, Project Settings, then Other Settings, and here you need to increase the bundle version code to something higher than the previous value, like 2 for example, and then you can rebuild your application, and this will allow you to update your application and push it on the MetaQuest Developer Hub to override the old one. Okay, so at this point, we've seen how to set the different settings on our Unity application to build an APK that is accepted by the Meta Store. Then we've seen how to use here this MetaQuest Developer Hub to push this application to one of the channels. And as you can see, this is already super useful during development if you want to send your application to multiple people and have them try different versions of your game. But what happens at the end when you are super happy with the result and that you really want to push it on the real store? So in other words, that your game is in production ready. So the technique is to simply add a new APK here to the production channel. You can also use another APK and simply change the channel. Like here, I can click over there, then push build to the channel and then select production store. And now we can click on copy. There we go. And now after waiting a little bit, this is what you should see. As you can see, we have also now an APK for the production store. And now with this APK, we'll be able to create our own store page. So let's go back to the meta dashboard. We can select our application. And as you can see here, we have now a button to start the submission, which we can click on. There you go. Now, as you can see, there is 4 steps before we can submit our application to the store for review. The first one is the submission, but as you can see, we have a warning. So let's click on view preference. And here I'm going to select everything and then click on confirm. Beautiful. Now we can give a name for the submission. For the contact email, you can just write your email address. It will not be seen by anyone else than the meta staff. So let's click on save change. There you go. We can now go to the pricing page and I'm going to set the listing type to full release. Now for the price, I'm going to set it to free. And by the way, if you want to make it a paid game, you actually need to first add some payment info. So basically the way that you'd like to be paid. There we go. Now we can save change and go to the next step for the build. Now on the build, I'm going to select the build that we want to send for the store page. And in our case, we only have one in production. So let's add it. There you go. We can then save or change. And now we need to go to the app metadata, which is the most important part because this is where we can add a lot of information about our game. And as you can see, there is a lot of things that we can add for description, but also on the details for all of the image, screenshot and more. So let's simply add a very short description. There you go. Once you've written a description and a long description, you can even add some search keyword, but then you can save your change. You can see that it has accepted all of the description that I've written. And we can go to the next step, the specs. So we can set our game to be early access. For example, for the game mode, I'm going to set it to single user. Supported controller, I'm going to set the touch controllers. For the play area movement, supported play mode, I'm going to add standing and room scale. For the comfort level, comfortable. For the internet connection, it is not required. For the subscription, it is not required. For the category, I'm going to set it to games. For the type of game, I'm going to set it to action. And no, this app does not contain any social feature. There we go, can save. We have a little V, which means that it has accepted our change. We can then go to details. For the details, I'm going to write the publisher. Then for the website, we can add the website of the game. Now for the privacy policy, it gets a little bit more complicated. Because you know that Meta is not very forgiving in terms of privacy policy. So actually what I've done is write some text here that I've actually get from another game. And I've basically changed here the project to take the name of my game, so Ghost Hunter. And to make the text public, I've put it on GitHub, as you can see. So now I can simply copy this file location and add it over there on the privacy policy. Now, if you need more information about how to write a privacy policy, there is a lot of documentation from Meta if you want to make it right. Now, anyway, the two last are optional, so we can click on Save Change. There we go. As you can see, everything seems to be good. So now let's go to the asset, and this is where we can add some images to our game. So this is, of course, the most important step. Now, look at everything that I've prepared for this tutorial. So these are all the images that you'll need. You first need a logo, which is 512 by 512. Then you need the same logo, but with a transparent background. Then you will need 5 other files. One which is 2560 by 1440. Another banner which is 3000 by 900. Another banner which is 1080 by 360. Then a vertical banner which is 1008 by 1440. Then a square which is 1440 by 1440. And then after that you will need 5 screenshots which will be 2560 by 1440. And there you go, a total of 10 images that you will need if you want to be accepted. So let's simply go back to the meta file. There we can add our transparent logo. Beautiful. We can do the same now with the non-transparent logo. There we go. We can drop the landscape now, then the square image. And there you go, guys. Now at this point, all of the images are uploaded. We have the logo transparent, the non-transparent logo. We have the cover art for landscape, square, portrait, mini landscape. We have the PDP art, and then we have 5 screenshots. You can also add a trailer and even 360 preview. But in my case, I think it will be already good like this. So I'm going to click on Save Change. As you can see, everything is good. So now we can go to the last setting, which we can set the content rating. And this is very easy to do. You can write here your developer contact email, and then you can create a certificate. So if you don't have any certificate right now, what you can do is simply click on request a new one. This will send you to a new page when you can answer some questions. So for example, the app type is game for me, and I'm going to answer everything no. There you go. Once you've answered all of these questions, you can finally click on next. And as you can see, this will generate to you a rating certificate. Mine is Peggy 3. And now we can click on this box and then click on finished. We can then click on close page, and this will send you back here to the meta dashboard where you should see this. Okay, and then finally we can click on save and submit. And now, as you can see, everything is green, which means that we have successfully managed to fill everything out. And now one thing is left, and it is to submit and click on this very important button over there that will send our application to Meta, which will allow our application to go on the store or not. But before we do so, we can first click on Start Preview, and what this will do is allow us to have a look at what we just made. So if I click here on the web store, then view PDP, as you can see, this will show us what our web page is looking with all of the files that we've added. We can see here our images, the different screenshots. We can see here the description that we've added, as well as the privacy policy right here. And if everything is to your liking, now we can go back to the developer dashboard, close the window, and then simply click on the important Submit for Review button. And there you go, now everything is done. If we go to the app overview, this is what you should see. You can see that the status of this app is now set to submitted, which means that it has correctly been sent to Meta, and that hopefully it will be on the store in a few days. Okay guys, look at what just arrived in the mail 1 day later. Our game has been approved by Meta. Congratulations! Now this means that the page is live and can be accessed publicly. At this point, everybody can wishlist the game, but it's still missing a release date, as you can see. So let's click on Setup Release. And there you go, this is what you should see. By the way, you can schedule also the build release by simply clicking over there on the app submission. We can give a schedule date, but in my case, I think it's good like this. Let's simply click on Release Now. And there you have it. Our game is now on the official MetaQuest store. How cool is that? Which means that it is ready to be seen and played by everyone. What a cool moment for any project. And even if the steps to do this take some time, I hope you enjoy watching this tutorial. And there you go guys, congratulations! Not only you survived this super long tutorial, but if you managed to get to this part of the video, it means that you were able to make something yourself that you should be proud of. Now, I love seeing what people make of my videos, so if you are sharing what you've done on LinkedIn or Twitter, don't forget to tag me as well so that I can see it. But anyway, thank you for following along. As always, you can support the channel by subscribing on my Patreon and get access to the complete source code of this project. Link in the description down below. Thank you again for watching and see you very soon. Bye bye!